What do we got? This is worksheet 7.4, number 5. All right, so here's what it tells us. It says a 20 kilogram object, so the mass of the object is 20 kilograms. It's acted on by a conservative force given by, so I'm going to put a little c here just to remind ourselves that it is in fact a conservative force. All right. And it tells you that it's negative 3x minus 5x squared with F in newtons and x in meters. It says take the potential energy associated with the force to be negative 55 joules when the object is at x equals 0. So my potential energy associated with that conservative force at x equals 0 is negative 55 joules. All right? And the question for part A wants to know what is the potential energy associated with that conservative force equal to if x is 5 meters. All right, so that is the problem that we are set out to solve. That was a weird sentence. Okay, so does everybody understand what's going on here? All right, so a real quick comment. I had 2 people come in and try to kind of do the same thing. Oh, no, I'm getting ahead of myself. Never mind. Okay. Okay, so somehow we need to find a way to get from this given force to potential energy, right? So what's the connection, you guys, between the force and the potential energy? Sure, or even get me partway there. I mean, what should I be thinking about here, you guys? Okay, good. A lot of you are saying integral. Great. So when you integrate, what does that give me? Does that give me the potential energy? It gives you the, I heard somebody say it, the negative change. All right? So here's what you should be thinking about. There are 2 ideas. All right? So idea number 1. I know that the work done by my conservative force is equal to the integral of my conservative force with respect to x. Follow? And I also know that the work done by my conservative force is equal to the opposite of the change in potential energy due to that conservative force. All right? So what I need to do is see if I can figure out a way to find out how much potential energy I've got here. So all of you guys are saying to integrate. Cool, let's integrate. Now what I would recommend, I saw a bunch of people, either came in before school or a tutorial or whatever, they tried to deal with the 55 joules while they were integrating, and I would not recommend that. Okay? And I know what you're thinking. You're thinking that's like the plus c. You know how when you integrate, there's like a plus c. You can solve it that way, and it does work, but it's not the way I would recommend doing this. All right? So let's just, I'm going to start with this equation, and I'm just going to do it exactly the way that it says. All right? So let me do this. Okay, so here we go. So the work done by my conservative force is the integral of my conservative force with respect to x. So that's the integral of negative 3x minus 5x squared with respect to x, right? Follow? All right? And really what I want to do is I want to figure out how much work is done between these 2 x values, right? Between 0 and 5, right? So since I'm integrating with respect to x, I'm going to put x equals 0 here and x equals 5 up here. Does that make sense or no? Okay, so integrate this thing. So what do I have to take the derivative of to get negative 3x? Oh, well that's negative 3 halves x squared, right? Minus, what do I have to take the derivative of to get 5x squared? 5/3 x cubed, right? And then I want to evaluate between 0 and 5. Any problems with what I did there? Everybody comfortable taking that integral? Okay, so now I can plug in my numbers, right? So if I plug in 5, you get, what is it? It's 248 point something, is that right? 245 point something? What is it? Cool, thank you. So this gives you negative 245.8 minus 0, and so that's what you get when you integrate. All right, so what this represents is not exactly the change. This is the work done by our conservative force. So look, you guys, based on this is the work done by the conservative force. But I somehow need to relate that to potential energy, right? So if the work done by my conservative force is negative 245, that means my change in the potential energy due to that conservative force is what? Positive 245.8 joules. Follow or no?
Oh, and then you just subtract 55.
Yes.
So, is it okay if we just put the C value as...
If you are able to do that and do it correctly, then yes, more power to you. All right, so is everybody good here? All right, so then my last step is this. Oh, well, my change in potential energy due to my conservative force is final minus initial. So it's the conservative force when x is 5 minus the conservative, energy when x is 0. So plug in your numbers. You get 245.8 equals my potential energy when x is 5 minus negative 55, right? So this is really plus 55, so to solve it, you subtract 55 and you're done. Good or no? Questions with what I did there? Yeah, Adam?
So my problem is just figuring out like which equations to use and when. So why would you want, like, why would you know to start with the integral x?
Like, why do you know to begin by integrating? Well, it's, how do I want to say this? The problem is about energy, right? The problem wants to know how much energy do we have when, okay? But most of the information that we're given is about force, okay? And so I guess it's, at some point you need to be making that connection between the fact that if your energy is changing, work is being done, right? And so you should be thinking, oh, my energy between here and here, between here and here, my energy is changing, so work is being done. Can I figure out how much work is being done? So that's one thought that you should be having, all right? And the other thought you should be having is, okay, well, what does all of that have to do with force? And the answer to that is this integral. You know what I mean? That work is the integral of force. So that sort of gives you two ways of thinking about that work, and then you kind of suddenly put to each other. Does that make any sense?
Yes.
Does that help at all?
Yeah. I was just confused because like our original work is force times distance equation. Like why would we just use that?
Okay, good. So let's talk about that. Why can't you just use that equation? Because the force is constant, exactly.
Okay. So when force is constant, that's what you do.
That's when you do the integral, exactly. Very good question. Very good. Great. Margaret, you okay over there? This is not me yelling at you for talking. Are you okay?